The previous example that we've looked at focused on units, but you can have a question that is given in batches. So I'm going to solve this question in batches so you can see how to deal with it.
Right. So let's work an example. Take, for instance, the first batch. Let's say each batch is made up of 100. So the first batch of 100 takes 20 hours. And the learning curve rate is 90%. Now we introduce a bit of technicality to this because remember, we said the learning curve does not continue forever. It gets to a point whereby there is no more effect. So I'm going to introduce that in these examples so that you can understand how you work it out if you find such in an exam. So let's say a steady labor hours. Steady labor hours will be achieved from 10,000 units. Now I want to calculate total time for 12,000 units. You see what I've done here? Now I've introduced the steady period into it, whereby the remaining 2,000 units, remember this is 10,000 units where steady rate is achieved. So which means if you are going to produce 12,000, there is 2,000 extra that would not benefit from any learning. So whatever rate of number of hours that we use to manufacture that 10,000, the last batch of 10,000 units would definitely be the same hours of rate that will be relevant for the remaining 2,000 units. So this is a good question to actually practice. Okay, so this is a batch, and because of that, we need to work it as a batch as well. So which means the so-called 12,000 units that we are asked to calculate is made up of about 120 batches. Yeah, that's 12,000 divided by 100 because one batch is 100. So we have 120 batches. However, we know that learning curve is only relevant to 10,000 units. This is where learning curve is relevant. So which means our workings, we need to focus on 10,000 units for now. And that will give us 100 batches. Just breaking down the question so you understand, right? So after this 10,000 units, we will achieve the no impact stage, whereby the learning is no more significant, right? So let's start with the average time per batch in this 100 batches. So if we were to produce 100 batches, what would be the average time to produce one batch? And we use the same formula, y equals to ax raised to power b. Y is what we want to calculate, and that equals to A is the hours of 20 that it takes to produce the first batch, right? So multiply by the total number of batches we're talking about is 100, and B, we don't know our B. So let's quickly do our B somewhere here. So B equals to log R over log 2. And that means B is equals to log 0.9 because the learning curve rate is 90% divided by log 2. If you do that, that will be equals to minus 0.152. So we already know our B here. So we can just put it here. So raised to power minus 0.152. And that will produce Y that is equals to 9.93 hours per batch. So which means it takes in a batch of total of 100, the average number of hours per batch is 9.93. So now that we know our B, we know Y to be equals to 9.93 hours per batch. Now we can know the total cost for 10,000 units, because we know 10,000 units will be equivalent to 100 batches. So which means anytime we produce these 100 batches, the average time for one batch is 9.93. Then that means the total for that 100 batches will be 9.93 times 100. And that will give us total hours of 993 hours for those 100 batches. And the 100 batches is equivalent to 10,000 units. Now we are left with 2,000 units. So we need to estimate the hours to produce 2,000 units. And 2,000 units will be equivalent to 20 batches. However, what we know is that learning curve is not applicable to this extra 2,000 units, because learning will cease at that point. And in that case, we need to get the exact time to produce the last batch in this group. And that last batch is the 100th batch. So the same concept we apply to this third batch when we say third unit alone is the same concept we're going to apply, but this is just a batch. So which means for us to know the time to produce the 100th batch, it means that we need to know the cumulative hours. We need to know the cumulative hours to produce 100 batches, and also the cumulative hours to produce the batch before that. That will be 99. The 99 batches, not 99th. 99 batches. So when we know these two, we know the cumulative hours to produce 100 batches, we know the cumulative hours to produce 99 batches. The difference between the two definitely is the time to produce the 100th batch. That is the same concept that we're going to apply. The total hours for 100 batches, we already know it, is 993. So which means we need to get the same thing for the 99 batches. So for 99 batches, we first need to calculate Y, which is the average time per batch in a group of 99. And that will be equals to the first, which is always 20. Now we're talking of batch of 99. Then B remains the same, raised to power minus 0.152. And that will give us 9.947 per unit, per batch. Yeah, and that means the total will be equals to 99 multiplied by 9.947, which will be 984.76 hours. So now we know the total for 100 batches, we know the total for 99 batches. So that means that the 100th batch must have taken the difference between the two. Must have taken 993 minus 984.76. Yeah, which is this minus this. And that will give us 8.24 hours. So which means it must have taken 8.24 hours to actually produce the 100 batch. And what this means is that any batch that we produce after this 100 batch will be produced using 8.24 hours per batch. And in that case, the remaining 2,000 units that we are talking about, which is equivalent to 20 batches, will consume 20 times 8.24 hours. And that will be equals to 164.87 hours in total. So which means now we know the total hours for 100 batches, which is 993. We also know for 20 batches now, which is 164.87. So that means we know for the total 120 batches, which is equivalent to the 12,000 units. And that will be addition of these two, which will be 1,157.87 hours. And that is the total. And I hope that is very clear. Quickly, another way the question can test you is to ask you to calculate the learning rate. But this is just pure mathematics. You need to know how to calculate the learning rate. So usually you'll be given information, and is this same formula you use, y equals to ax raised to power b. So the first thing is always do this. Step 1, you need to calculate b for sure. So then step 2, you can calculate r from b. Because once you know b, r is easy. So let's use an example to solve this. So let's assume that we have 64 batches. So let's have a question quickly. So let's say 64 batches took average of 10.3 hours per batch. Yeah? And the first batch took 25 hours. Then calculates the learning rate, which is R. So they've given you 64 batches and the average per unit, which is Y. So if you remember Y equals to AX raised to power B, Y is already 10.3 because that is the cumulative average per unit. And that equals the first batch hour, which is 25, multiplied by the cumulative batches of 64 raised to power B. In that case, 64 raised to power B will be equals to 10.3 divided by 25. If you do 10.3 divided by 25, that will be equals to 0.412. Now, we have 64 raised to power B equals to 0.412. And you'll be wondering, how do you solve this mathematics? If you're comfortable with math, this will not be strange to you. But even if you're not comfortable with it, I can quickly teach you. So anytime you get to this point, where is power B, and you need to solve for B, what you must do is to add log to both sides. So add log, logarithm on both sides. Once you add log on both sides, what you have now is log 64 raised to power B will now be equals to log 0.412. And anything that is raised to power in log, you can bring it to the back of the log. That is the rule in mathematics. Yeah, by the time you practice it a couple of times, you get used to it. So which means this is the same thing as B log 64 equals to log 0.412. And B is now going to be equals to log 0.412 divided by log 64. Then you can press your calculator, logarithm of 0.412 divided by logarithm of 64, and that will give you a B that is equals to negative 0.2132. Now that is step 1. We've calculated B. Now it's time to calculate R, which is your interest. But you know that B equals to log R divided by log 2. So which means this equation is equals to negative 0.2132. And if that is the case, it's easy to do log R. Log 2, we already know it. It's a constant figure we've been seeing all day. So, but let's just get it quickly. So log 2 is 0.3010. So which means that log R will now be equals to cross multiply, yeah. Log 2 is 0.3010, then multiply by 0 minus 0.2132. And that will be equals to negative 0.064. So that means log R is equals to this. Now, what we are interested in is R and not log R. So which means we need to find a way to cancel that R away. Sorry, that log from the equation so that we can have R. So this is also mathematics. If you're very solid in maths, you will not struggle with this. But as I said, if you're not, just learn it right now. So anytime you have a situation like this, again, I'll tell you what you need to do. All you need to do is to remove the log. So let me put it down for you. So remove that log by making minus 0.064 as the power with, I'll explain what that means, with base of 10. Remember, if I say 2 raised to power 3, it means the power is 3 and the base is 2. So which means to take care of this situation, to cancel this log away, we need to do this on the other side, which means we need to make 10 the base. Remember, make 10 the base and raised to power minus 0.064 is a mathematical rule that you need to memorize. So by the time you do that on this side, the log here is cancelled out. That's what has happened. So with that, you can cancel out the logarithm. So log R will become R immediately because this log will go away. And at that point, everything is easy because your R automatically becomes 0.86, which is the same thing as 86%. So that is your learning curve rates, and learning curve is no more than that. Finally, let's just finish it with the limitations. Like I always like to do, there is no perfect technique. Like we looked at the other methods earlier, they all have limitations, and learning curve is not an exception. The first limitation with this is the fact that production must be continuous for us to learn from it. So production must be continuous. That might not be the case all the time. So which means learning curve might not be applicable in that sense if it is not continuous. Likewise, for learning curve to make sense, tasks must be very repetitive. That's when it's easier to learn and you can achieve some efficiency. So tasks must be repetitive. And all this effort we are talking about it will only worth it. So this process only worth it if we are looking at complex activities. So only worth it if activities are complex. So if it is not complex, there's no need to bring in learning curve. Nothing to learn. It is simple. Yeah. And most importantly, your staff must be motivated to learn, because if not, they will be frustrated and they will just abandon it, or they will never improve, or they will keep wasting things. Yeah. So you might not achieve the efficiency you think you will achieve. So staff must be motivated to learn. You have to make sure they are motivated to learn. That's how you're going to get those efficiencies that we are talking about. If not, learning rate will just be 100%. So which means there's nothing reducing. The number of hours we are using is the same number of hours. So the last part is the fact that different products will always have different learning rates. So it might be difficult to apply one learning rate in a company if you have more than one type of product. So these are the limitations of learning curves, which you need to take note of can have it in your MCQ questions, or maybe all those sub questions. That might be 2 marks, 3 marks. And that'll be it. In the next video, we're going to be looking at variances. Thank you guys. Bye now.